So let me share the screen. I think the screen is visible to you guys now, right? Screen ki dekhte paccho? Okay, so today what we are going to discuss is vector and scalar. Vector and scalar, basically, and we can say vector quantity and scalar quantity. So in physics, what we do mostly is we do measurement. We measure various systems. We measure the length of an object. We measure distance, right? We measure mass of an object, like the time period or this kind of thing. Always we measure. So the thing that can be measured are called quantities. Things that can be measured are called quantities. So, and there are two kind of quantities. So basically there are two kind of quantities based on the direction. Based on their direction, quantities can be divided into two categories. One of them is vector, and the one is scalar. So once we say quantity, definitely every quantity has some magnitude. প্রত্যেকটা quantity magnitude থাকে. And then they are divided based on their direction. If a quantity has a direction, then we call it is a vector. And if a quantity does not have a direction, then we call them as scalar quantity. I think all of you are familiar with these things. So a vector quantity has both magnitude and direction. For example, here for example, let's say this is the direction of an object. This is the like displacement of an object. It has a magnitude. U is a magnitude. Is this visible or legible? তোমরা কি দেখতে পাচ্ছ লেখাগুলো বা ফিগারটা?
Yes, sir.
Okay, so like let me use another page, I guess. So no, more convenient for you guys. So if I say it is a vector quantity, like let me start with vector quantity. If I say that, like, okay, vector quantity, so vector quantity has two things. Okay, vector means it has both magnitude and direction plus direction. Whereas a scalar quantity has only magnitude. It does not have any direction. So for example, a people, a man, he starts from point A and he starts moving. He starts moving, like, so I'm saying that, okay, he's moving from A to B, say 50 meter move korbe. Okay, he's going to travel 50 meter. So it can be this way, it can be that way, 50 meter north, 50 meter south, or 50 meter like west, any direction সে মুভ করছে। So আমি যদি তার শুধু ডিসটেন্স বলি, the distance of an object is 50 meter and not telling anything about the direction, then its displacement of its distance become a scalar quantity. And in case of vector, যে কোনো একটা vector যদি আমি বলতে চাই, okay, a vector not only have a magnitude. For example, an object starts from point A and it reaches point B. So let's say the distance between A and B is 50 meter. So its direction is 50 meter, its magnitude is 50 meter. And আমি বলে দিচ্ছি, let's say this is X direction and this is Y direction, and it is making an angle like maybe theta equal to 30 degree with X direction, axis. And বলছি an object is traveling from A to B, which is 50 meter, and his trajectory and the way he is moving, it is making a 30 degree angle with the positive x-axis. That means আমি তার ম্যাগনিটিউডই শুধু বলছি না, at the same time আমি specifically বলে দিচ্ছি the direction of the object. So in this case, this is a vector quantity. So vector quantity has both magnitude and direction. Example for vector quantity, it can be like weight, right, and maybe displacement, velocity, etc. And for scalar quantity, it can be like mass of an object, right, time, height, right. These are some example of scalar quantity. So in today's lecture, what we'll be doing, we will be learning some basic algebra or basic math that are related to scalar and vector quantities. That means math means, in a sense, that how to add them at the scalar and vector quantity, how to represent the scalar and vector quantity, how to multiply them. Okay, So that's the thing that we are going to discuss in this class. Okay. So now, first thing first, how to represent a vector quantity. How to represent a vector quantity. Okay. How to represent a vector quantity. So when I am writing a vector quantity, let's say velocity is a vector quantity. When we say, okay, velocity is a vector quantity, that means we have to represent a vector quantity. What we do, most often we put a additional arrow sign on top of that. If an arrow is here, we can say, okay, this is a vector quantity. V for velocity, let's say, is a vector quantity. Or আমি যদি এরকম বলি যে u is a scalar quantity, or if I say, okay, u is a quantity, but it does not have any arrow on top of it. So we can say, okay, this is a scalar quantity. So this is a scalar quantity, and v is a vector quantity. So this is how we represent a vector. যখনই আমরা একটা vector লিখি, তখন on top of that we put an arrow sign. Oftentimes, or sometime what people do, instead of putting an arrow, they just put a bar. এটাও represent করে একটা scalar quantity, sorry, vector quantity. This is also vector quantity. But আমরা most often এটা use করি না, or most often আমরা এটা use করি. Okay. And আমি একটু বলতে চাই, in any point, at any point of my lecture, if you guys face any difficulties or any confusion, you can ask it to me. Okay, আমাকে question করতে পারো. So this is how we can represent a vector. Now in today's lecture, at first we are going to discuss how to add to vector, okay, how to add them, how to add the vectors. So adding vectors, vector in general, vector can be add by two ways. One is like geometrically. One way is to add them geometrically, and the way object is to add. The second way is I can add them like mathematically. So mathematical adding I'm going to discuss later. Let's start at first how to add them geometrically. So there are two methods. Basically, there are two methods for adding vectors geometrically. One is a triangle method or head-to-tail method, and the other one is polygon method. So, for example, u is a vector and v is a vector, and I want to add them up. Or let's say I have two vectors. Okay, let's say I have two vectors. One is u. Let's say we have two vectors. One is u, and another one is v. Okay, u is a vector and v is a vector, and I want to add them up. And I'm telling, okay, r u vector plus v vector means r vector. U and v, these are two vectors, and if I add them up, then I'm going to get a vector that is r. How to get them? So the simplest way is to use triangle method, that is head-to-tail method. It is like this. So at first, let's say this is my vector u, and this is my vector v, for example. So, and the resultant vector will be, you have to get the resultant vector. What you have to do, you have to start from the tail of the first vector. That is, this is the tail of the first vector, and you have to take the head. You have to take the tail, yes, there, and you have to take the head of the second vector. This is the head of the second vector, and you have to draw a straight line from here to here. So tail of the first vector will be the tail of the resultant vector, and head of the second vector will be the head of the resultant vector. So this one, or let me take another pen, like red one. So the red one will be my resultant vector. So this is r basically. R means u plus v. Okay, r means u plus v. So this is the like triangle method, and the other one is parallelogram method. Because not all the time we can use like or sometimes you might find using triangular method is a bit difficult. In that case, you can use parallelogram method. So in this case, what you have to do, you have to place both the vectors u and v at the same initial point. In this case, what do you have to do? Let's say you have 2 points, one is u and the other one is v. You have two vectors, one is u vector, okay, and the one is maybe v vector. And I want to add them up. So what I have to do, I have to start with a common initial point. So this is my u vector, and this is my v vector. Okay, so both of them have a common initial point or same initial point, and then I have to draw a parallelogram using u and v. So This is U, and this is my V. Same as here, U and V, and then you complete the parallelogram here, and the diagonal. And the diagonal in that case, the diagonal will give you the resultant diagonal. Okay, let me draw it in red. So the diagonal will give you the resultant. So the diagonal is U plus V. So this is how we can get the resultant of a vector. Okay, so same again. If I have two vectors, I have to place them at the, at the same point, or আমি তাদের টেলগুলোকে একটা same point এ নিয়ে আসবো, and then I have to complete a parallelogram, and the diagonal of the parallelogram will give me the like resultant vector. Okay, so this is how we can add vectors geometrically. But the thing is, the next way is how can I like add them mathematically. So if I want to start with math, at first I have to say, okay, how to represent a vector mathematically. কোন একটা এক্সপ্রেশন দিয়ে আমি কি করে একটা ভেক্টরকে রিপ্রেজেন্ট করতে পারি, how to represent a vector mathematically. That one I am going to discuss first. Okay, so before going to the details of that, let me tell you guys what are the components of a vector. What are the components of a vector? Okay, vector component গুলো কিভাবে রিপ্রেজেন্ট করব. So let me take another page. So the components of a vector. What will be the component of a vector? So and to find the component of a vector, I have to take the help of Cartesian coordinate system, that is x coordinate and y coordinate. Okay. So now my job is to find the component of a vector. Let's say this is a vector. Let's say this is a vector. Okay, this is a vector. Okay, this is the vector V, or let me write it like A. Let me tell it A. A is a vector. Okay, A is a vector. A is a vector quantity, and I want to know the component of this vector A. So to get the component of vector A, what I have to do at first, I have to place this vector A in a coordinate system, Cartesian coordinate system, more specifically if I say. So in a Cartesian coordinate system, in 2 dimension, we have an x coordinate and then a y coordinate, right? We all know this. X is the horizontal axis and y is the vertical axis. And then what I have to do, I have to place this vector over here. So this is I can start from the origin, no problem. Okay. So this is my vector A, for example. This is my vector A. And since it is a vector, since A is a vector, definitely A makes an angle. A is going to make an angle with the x direction or y direction. Let's say A makes an angle theta with the x-axis. A makes an angle theta with the x-axis. Okay. And now A has a component. Definitely A should have a component along x direction, and A has a component along y direction. Okay. So what is the component of A along x direction? Component of A along x direction is the projection of A on x-axis. The A এর যে projection থাকবে along on x-axis, that will be the component of A along x-axis. So projection of A on x-axis is A cos theta. A cos theta is the projection of A on x-axis, and this is called the x component of A. This is called the x component of A. That means AX. Okay. This is called the x component of A. And similarly, A has a component on y direction, on y-axis. What is the component of A on y-axis? This should be, again, this is the projection of A on y-axis. Okay, so let's name it A. This is A y, and this is my A x. So what is A y then? A y means, if we want to take the projection of A on y-axis, this should be A cosine of, if this angle is theta, so this angle is what? This is 90 minus theta. Cosine of 90 minus theta. So this should be basically equal to A sine theta. So this is how the component of a vector can be figured out. That means if a vector is given to me, I can easily find out its x and y component. Only if the angle or the direction is given to me. আমাকে যদি ডিরেকশন বলে দেওয়া থাকে, আমি ইজিলি ফিগার আউট করতে পারবো the x and y component. And here theta is a direction, and by the way, A is what here? It take to clear code. What is A here? A is, see here, I did not put any arrow on top of it. So this A is basically magnitude of vector A. Okay, right? So let's start. Start with an example for this. So let's say this is a vector. This is vector A. Okay, this is vector A, and it makes an angle 30 degree with x direction. So my x component AX will be equal to what? Will be equal to magnitude of A and 30 degree sine, cosine of 30 degree, right? So cos 30 degree equal to what? Can anyone tell me? Cos 30 degree? Right, to follow. And let's say the magnitude of A equal to 5. So 5 cosine of 30 degree. Right? And same, bolo কেউ কিছু বলছিলে বোধহয় cos 30 equal to
root 3 by 2.
Root 3 by 2. Thank you. So AX equal to AX is equal to, then AX is equal to this already, you guys know this thing, 5 into root 3 by 2. And same here, AY equal to A sine 30 degree. My theta is 30 degree here. So this should be like 5, and sine 30 means half. So this is equal to 5 by 2. So this is how we can find out. This is how we can find out the component of a vector. This is how we can find out the component of a vector. And then now the component of a vector is clear to me. Now again, so if a vector is given to me, for example, A is a vector, I can easily figure out this component like AX and AY. Or like a vector has magnitude 5, and if I am given, or if let's say if someone tell me, okay, it makes an angle 30 degree with x direction, I can easily find out the x component and y component. Now my question is how to represent this vector mathematically. A vector is given to me, and now how I'm gonna represent it mathematically. Okay, mathematics কিভাবে represent করব. So and for that I need an unit vector notation. So let me start with a new slide. So the title should be how to represent a vector mathematically. Okay. So let's think. I have a vector, something like this. This is my x direction, this is my y direction, and I have a vector A, right? And this is my vector A, and I know that A makes an angle theta with x direction. And now I know its x component is AX, for example, and y component is AY. And AX, what I know from my previous understanding is that AX equal to A cosine of theta, and AY equal to A sine theta, right? And my question now is I want to represent this vector A mathematically so that I can do some math using this vector. How to represent this? So to represent this mathematically, I need some unit. I need some unit. You guys, all of you are familiar with the term unit, right? For example, when we measure distance, we use some unit like meter or centimeter, right? If you want to know the weight or mass of an object, you use kg. So similarly, if in case of vector, you also, to represent vector, you need some direction, or you need some unit. You need some unit, or I can say unit of direction. Unit of direction. Directionের কিছু unit আমার জানা দরকার আমি যদি ভেক্টরকে রিপ্রেজেন্ট করতে চাই. So what is that, and how to represent that? Let's say this is my x and y coordinate system. Okay. So along x direction, a unit distance, আবারও বলি, অ্যালং এক্স ডিরেকশন একটা ইউনিট ডিস্টেন্সকে তো আমি রিপ্রেজেন্ট করতে পারি। ফর এক্সাম্পল, তুমি এখানে 10 মিটার ডিস্টেন্স ট্রাভেল করলে, ওকে, and when you travel a distance of 10 meter of 10 meter, দেখো এখানে ইউনিট ইজ মিটার, বাট ইফ ইউ ট্রাভেল ডিস্টেন্স অ্যালং এক্স ডিরেকশন, তাহলে তোমাকে কি করতে হবে, ডিরেকশন স্পেসিফিক কিছু ইউনিট বলতে হবে। সো ইন অ্যালং এক্স ডিরেকশন the unit of direction is I. Okay, so I is a unit vector for x direction. So x direction unit vector কে আমরা বলি I, and along z direction, y direction, the unit vector is represented by z, And by the way, I put an additional sign, a cap sign here. This cap represents unit. So cap represents unit. So I is unit vector. I is unit vector along x direction, and j is unit vector along y direction. So this unit vector I need to use. And now let's go back to my discussion point. We want to represent a vector mathematically. So now we can rewrite a vector like this. So the vector A can be written as, or can be written as like this. A vector, দেখো আমি কি লিখতে পারি কিনা, A vector means ax plus ay. হ্যাঁ, A vector means ax plus ay, সেটা আমরা বলতে পারি, because তার একটা x component আছে and he has a y component, ax plus y, ay. But what is the problem? The problem here is, let's go back to the previous problem. Math. See, ax is what? Ax means 5 into root 3 by 2, and here ay means 5 by 2. So আমি যদি এই ম্যাথটার আলোকে আমি ভেক্টরটাকে লিখি, if I write the vector in terms of that math, তাহলে this becomes ax plus ay equal to 5 root 3 by 2 plus 5 over 2. Just have a look at it. So এখানে it contains only the magnitude. It contains only the magnitude. কোন ডিরেকশন কিন্তু এখানে নাই. There is no direction here. আমার এই লেকচারটা যে শুনবে না, সে just এসে যদি এটা দেখে, if he just take a look at this, he will say, oh, what is the direction here? You were saying that, okay, A is a vector and 5 into root 3 by 2 plus 5 by 2. This is just a number. This is just a number. No direction is here. So I have to put a direction here. How to put a direction here? I have to say, okay, 5 into root 3 by 2. This is the component of this vector along x direction. So since this is a component of a vector along x direction, I have to multiply this with I cap. And this 5 by 2, this is a component of vector along y direction, I have to multiply with j cap. So once you multiply this thing with I cap, what happens is, you see, I is what? I is a unit vector. Unit vector means its magnitude is 1. Unit vector means its magnitude is 1. অর্থাৎ তার ম্যাগনিটিউড হচ্ছে 1, তার মানে সে তার ম্যাগনিটিউডের মধ্যে কোনো চেঞ্জ দিবে না, সে শুধু বলবে এটা যে এই কম্পোনেন্টটা x এর দিকে আছে, because আমি এখানে যদি explicitly x লিখেছি, এখানে কিন্তু লিখিনি, so I will not change the magnitude. সে just বলবে যে it is traveling along this direction, and j again will say, okay, this is the component of the vector, this is traveling along y direction. So what I can do, I can write a vector as like axi plus ayj. If some number is written in this way, then I can easily find out the x component and y component, and I can say, okay, this is a vector. Okay, clear? So this is how we can represent a vector. Or I mean, I can write this as like ax means a cos theta I plus ay j. Okay, so this is how we can sorry, ay means a sin theta. Ay means a sin theta into j. Okay. Y means a sin theta into j. Okay. So this is how we can represent a vector. And for example, and this expression is in particular is very useful. Like for example, if I tell you something like this, okay, this is my vector, like okay, so for example, let's say my vector is like this. Let's say my vector is like this. Let's say and the vector b vector. B vector means 5i plus 6j. 5i plus 6j. So if you have a look at this vector, 5i plus 6j, by looking at it, you can easily say, okay, what is my x component and what is my y component? Just having a look at it. What is the x component of this vector? Actually, what is the x component? X component is 5 because I is always with the x component. যেখানে I থাকবে, the coefficient of I will represent the x component, and similarly the coefficient of j will represent the y component. So the y component of the vector b is 6. So we can also write like, okay, bx equal to 5 here and by equal to 6. Clear? বুঝতে পেরেছি আমরা?
Yes, sir.
Okay, thank you. And then
Yes, sir.
okay, thank you. So this is how we can represent a vector. Okay, and then so I write something here. You can read it by yourself. This will be helpful for you guys. So I'm not going to discuss this page. So now the thing is here, if you say, if you just see here, the vector we write here, these vectors are actually in like two-dimensional vector. They are two-dimensional vector. But what we know is that the space is three-dimensional space. So vector can be three-dimensional as well. So how to represent this kind of vector? How to represent a vector that is in three dimension? So let's say like three-dimensional case. So three-dimensional case. So how to represent a three-dimensional vector? So so far we discussed two-dimensional vector. It has one in along x direction, the other one is along y direction, right? So vector has two components, and in order to represent a vector, we use unit vector. Unit vector along x direction is I. Unit vector along y direction is j. This is what we know so far. And also in 3D, we use another axis that is called z axis, right? That is called z axis. This is my z axis, and the unit vector along z direction is like k. K is the unit vector along z direction. Okay, so now if you want to represent a vector in 3D or two dimension, then we can write this as like a vector. That means ax into I plus ay into j. Okay, so this is a two-dimensional vector, and in case of three dimension, definitely the vector should have a z component. Okay, and in case of z component, we have to multiply this by a unit vector k. This is the unit vector along z direction. So this is how we can represent a vector in 3D. Okay, so now so far we know how to represent a vector. Okay, now let's back to our point, the one that I was telling you, that I wanna add the vector mathematically. What I wanna do, I wanna add the vector mathematically. So how to add them mathematically? If two vectors are given to me, I want to add them mathematically. So let's discuss it here. Okay. So addition of vector mathematically. So of vectors, okay, in a non-geometric fashion. So let's say I have two vectors. One vector is like this: a is equal to 3i plus 4j, okay? And another vector is b. So, or let's write it in more generic form. Okay, at first let's write it in generic form. Like more general form. Let's say I have a vector a. A means ax I plus ayz, and b means bxi plus byz. Okay, so these are the two vectors, and I want to add them up. Let me add code. So what should be a plus b? So if I want to add two vectors, I have to add the like component. So I have to add x component with the x component and y component with the y component. That means I have to add ax with bx, because both of them are x component. They share the same unit vector I, And similarly, I have to add AY with BY because both of them have the are along the Y direction and has the same unit vector J. AY plus BY. Okay. So this is how I can add them up. So to make the thing more clear, let's do some real life math. Not real life math. Let's do some example. Let's say I have two vector. One is a vector, a equal to 3x plus 2i. Oh no, not 3x, 3i plus 3i plus 5j. This is vector a, and other vector v. B is equal to 9i minus 2j. So a plus b would be, or the resultant vector a plus vector b will be equal to 3 plus 9i and then plus 5 minus 2j, right? So because what I did here, I add the like component. I added I with I, j with j. So 9 plus 3 is 12 plus 5 minus 2 equal to 3. 12i plus 3j. This is my resultant vector a plus b. So this is how I can add some vector mathematically. This is how we can add vectors mathematically. Clear? And also, I want to tell another thing, one more thing I want to discuss. That is if I have a vector like this. Let's start here. So let's say I have a vector. Well, let's take a new page. I think that will be more fun. No, let's say do here. So, and the thing is, I want to find out the magnitude of a vector. I want to find out the magnitude of a vector. By the way, at this point, I want to discuss the 2D case, two-dimensional case. Okay. So let's say vector A is written as AXI plus AYJ. This is vector. Vector A is represented as like AXI plus AYJ. In that case, the magnitude of the vector. So this absolute sign or modular sign represent the magnitude. Okay. See here, the two sign here means magnitude of A will be actually equal to AX square plus AY square. Okay. So this magnitude of the vector. So let's say, let me write in another way. So a vector is like this, ax plus I plus ayj. So we can write the magnitude of the vector of vector A is like this. So, or you can actually write only A. This also means the magnitude equal to x component square root of x component square plus y component square. This will give you the magnitude of the vector. So actually, how it came, I'm going to discuss it maybe in our next class. So let's move forward and try some math. So this thing, I'll discuss maybe tomorrow in our next lecture. Let's try a math here. So this is again, this is from our book, the textbook by Resnick, Halliday, and Walker, 9th edition. I already, I think, share the link of the book with you guys. And this is from section 3.4, and this is math number 1 of the book. What are the x component and y component of a vector A in the xy plane if its direction is 250-degree counterclockwise from the positive direction of x, and its magnitude is 7.3 meter? You can read it once again. What are the x component and y component of a vector A in the xy plane if its direction is 250-degree counterclockwise from the positive x direction, and its magnitude is 7.3 meter. So what they are saying, a vector is given to me. A vector is given to me in an xy plane. So this is my x, this is my y, and this is my a, x, and the magnitude of the vector, এখানে বলা আছে, this is actually 7.3 meter. This is the magnitude, and the direction is what? It makes 250 with the positive x direction, counterclockwise. So clockwise means along this way, right? And counterclockwise means this way, right? So this is the clockwise and this is my anti-clockwise. So this way. So starting from x-axis, see, 250 counterclockwise from the positive x direction. So this is my positive x direction, and from here it is traveling 250 degree. You can see here 180, 250, right? So this is my 250 degree, for example. Right? This is the vector. This is the vector A. This is the vector A. Okay. This is my vector A. Clear? Is it clear to you?
Yes, sir.
Okay. And then looking at it, and then what I have to do, I have to find out the AX and AY. I have to find out AX. So this guy will be my AX, and this one will be my AY. This is my AY. Okay. So this is what I have to find out. So I have to find out AX. So AX is what? AX means, I know AX means A, and then magnitude of A cos theta. So here theta is 250 degree. Theta means 250 degree. So that would be equal to magnitude of A is 7.3 cos 250 degree. So I left this math for you guys. You can easily find out the value of 250 degree and find out the value. And similarly, AY means A sine 250 degree, or A sine theta, A sine theta, A sine theta. So this is basically equal to 7.3 sine 250 degree. And basically, this will give you the component. This will give you the component, x component and y component. This is my x component and this is my y component. Clear? Actually, you have to now use the calculator and find the value of cos 250 degree and multiply it with 7.3. This will give you AX, and multiply 7.3 with sine 250. This will give you the value of AY. That's it. Here is another math number 2. The displacement, a displacement vector r in the xy plane is 15 meter long and directed at an angle theta equal to 30 degree. Determine the x component and y component of the vector. Same again, a vector is given, this is r, okay, whose magnitude is 15 meter, and it makes an angle theta with the positive x-axis. So from here, I can easily say it's the same again. The magnitude here again is what? Magnitude is given here. What is the magnitude? Okay, 15 meter long. This is my magnitude. Okay, this is a vector r. It makes an angle theta with positive x-axis, which is 30 degree. So theta equal to 30 degree, and magnitude of r equal to 15. So, and theta equal to 30 degree. And I think we did similar kind of math. Yes. So component of r along x direction, that is rx equal to r cos 30 degree. Oh, okay, anyway, 15 cos 30 degree. So that's 15 into root 3 by 2. And same again, ry means r sine theta, that is equal to 15 sine 30 degree, that is 15 multiplied by half. So this is the component of r along x and y direction. Okay, this is the components of r along x and y directions. And now, so in book you'll find a similar kind of math, and actually I'm gonna share with you some math, or I'll write it down in your what I say, in your studio or box. What are the math that you have to do? Okay, so you see it. Okay, and then okay, addition of vector by component. Actually, I already discussed this thing, so I don't want to say it again. So addition of vector by component. Okay, this is addition of vector by component, and let's try the last math here today. Okay, last math of the day. So you see, can you see the slide, guys? Slide দেখতে পাচ্ছ? This is the last math of the day. So this slide is showing you 3 vectors. One is vector A. This is vector A, and the vector A is represented by 4.2i minus 1.5j. This is vector A, and this is my vector v. This vector v is like minus 1.6 m along x direction and 2.9 m along j direction. This is my vector v, and my vector c. This is my vector c. This is minus 3.7 j. 3.7 j. And then what is there? And they are saying, okay, what is their vector sum r, which is also shown. So আমাকে বলছে যে this r is the vector sum of a, b, and c. R is the resultant, or if you add a, b, and c, then you are going to get r. So they are asking me to find out r. They are asking me to find out r. Or in other words, they are asking me, okay, represent r mathematically. Represent the vector r mathematically. That means r equal to a plus b plus c. So here it is very easy, I think. You all know this. A equal to 4.2 I minus 1.5 j, and my b vector is equal to minus 1.6 I plus 2.9 j, and vector c is basically equal to minus 3.7 j. So let's write here minus 3.7 j. And then what I have to find? I have to find that r. R is what? A plus b plus c, right? A plus b plus c, or sum of the three vectors. So a plus b plus c, that means I have to add all these components. So I have to add the like component. So 4.2 minus 1.6 into I, and same here, plus j component. I have to add all the j component, minus 1.5 plus 2.9 minus 3.7, and then j. Okay, so a plus b plus c means r. So I can say like, okay, vector r is actually equal to 4.2 minus 1.6 means 2.6 I, and then 1.5, then it should be like 1.4, and 3.7 minus 1.4 will give you 2.3. So so basically this is the vector r. This is the vector r. Is it clear to you guys?
Yes, sir.
Okay, so I think my time is almost up, so I'm going to finish it here today. And then let me stop the recording first. So